So in 6, now we're doing a dilation, still about the origin, about that point D, but now we're making it smaller, 1/3 the size smaller. And whenever you're dealing with difficult scale factors, not whole numbers and not like a half, you kind of want to dissect this into a slope problem. You're going to dilate each point individually from your origin or your point of dilation to an endpoint on the figure. And you just want to look at, how much are you rising and how much are you running. And you're going to multiply that by your scale factor. And that will tell you your new run. That will tell you your new rise. So -3 times 1/3 is -1, and +3 times 1/3 is +1. You're really just going to go 1/3 of that red distance. You're really just going to go 1/3 of that run on the red distance, and you're just going to attach it to your rise. So if we were to only rise 1, do that +1. And if we were to only go -1 on the run, this would be B prime. And we can see that this is the same thing for C prime. It's just that now we're, going down 3 and to the right 3. So if we go 1/3 of that, if we don't go the full 1, 2, 3, if we don't go the full way, if we only go just one piece of that, right? So you have 3 pieces fit in there. If we only go 1/3, boom, there. If we only go 1/3 of our run, then we're going to wind up here at C prime. And you might not believe me, so we'll do the same method. We'll multiply our rise by the scale factor and our run by the scale factor. And you can see that becomes -1 and +1. And that's where we're getting the go down 1 and go to the right 1. So we get that point here for C prime. And I'm going to clean this up just a little bit so you can pause, and if you need to think about that, you can pause and take a look. But now we're going to go deal with our last piece, A prime. So A, this is like the easiest one, because to get from our point of dilation B to A, we just went a run of -6. So we want to multiply that by our scale factor, 1/3, and that's going to be -2. We're only going to go to the left 2. And you can see that to the left 2, that's literally 1/3 of that entire segment. So if we connect all of this, I'll clean up all the pieces we don't need. We'll delete the B by accident. Oops. And we connect that into this red triangle. You can see our new triangle. And you might notice that when you dilate this line BC, take a look at BC, and take a look at where the point of dilation is. See how that point of dilation, let me do it a little bit differently. See how that, one more time. See how that point of dilation is on the line? It kind of just stretched it out on the ends. The line didn't change its y-intercept. It stayed exactly where it is. And that's kind of foreshadowing what we're going to do tomorrow. But, for this problem, here's our new triangle. That's 1/3 dilation. You can still see all the corresponding sides are still parallel. Even this is parallel to itself. Alright, now we're on to the bonus.